Okay, so today we're doing the last topic, which is quadratic equations, but real world situations, so word problems. These are not that hard if you just pay attention. The most common real life situation that could be described by a quadratic equation is the motion of an object under the force of gravity. Two examples are a ball being kicked into the air or a rocket being shot into the air. Okay, piece of trash. A high school football player is practicing his field goal kicks. I mean, think about it. When a football player is kicking a field goal, doesn't go up in the air and then it comes back down, so it forms a parabola. No, think about it. If it's, hold on. Okay, here's where he kicks the football from. Okay, here's the football. Okay. It will go up through the uprights, and then it'll come back down. It doesn't just go through here and fall straight to the ground. It travels a little behind the uprights, right? Okay, say there's not a net there. Okay? Say there's not a net. It's going to form a parabola. Okay? A negative parabola, right? Because it's upside down. So, the equation to represent this scenario is negative 9t squared plus 45t, where t is the amount of time in seconds and s is the height in feet. So where will the ball be at 4 seconds? So 4 seconds after he has kicked it, where will the height of the ball be? Wouldn't you just replace both of those t values with a 4? Because look, t is time. Well, isn't 4 seconds time? So you would replace both t values with 4. Now type that in and see what you get. Pay attention. Pay attention. Okay, what'd you get? $36 what? No, 4 was seconds. So after 4 seconds, the ball is 36 feet in the air. Look, they worked it out for you right here. Okay, so now that we've done that one together, I want you to try question 2 at the bottom by yourself. Okay, go ahead and try question 2. Brendan is tossing a ball in the air. He knows the height of the ball is represented by the equation s equals negative 12t squared plus 50t, where s is the height of the ball and t is the time. How high in feet will the ball be after 4 seconds? So Maggie, they've given us one number in the question. It's 4. Where does the 4 get plugged in, the s or the t? Yeah. Correct, because look, s is height. We don't know how high it is. We don't have anything to plug in for s yet. But t is time, and 4 seconds is time. So in both t places, you'll plug in a 4. When you plugged in a 4, what did y'all get? 8 feet. So that means after he tosses this ball in the air, 4 seconds later, it's 8 feet in the air. What about after he has tossed it and it's been 1.5 seconds? How tall or how high is it? Okay, well, how does that make sense? How can it only be 8 feet in the air after 4 seconds, but after 1.5 seconds, 48 feet in the air? How does that make sense? Right, the ball has come back down at this point. 4 seconds into it, it's coming back down, almost back to the ground. Does that make sense to everybody? Okay, turn to page 23. Go ahead and try number 1 by yourself on page 23. Eric is at the top of a cliff that is 500 feet from the ocean surface. He is waiting for his friend to climb up and meet him. As he waits, he decides to start casually tossing pebbles off the side of the cliff. The equation that represents the height of this pebble tosses is s equals negative t squared plus 5t plus 500, where s is distance in feet and t is time in seconds. After 25 seconds have gone by, how far from the ocean will the pebble be? So what do we do with this 25? Plug it in for t, because t is time in seconds. So that 25 goes in the t. So S equals negative 25, parentheses are so important, squared plus 5 times 25 plus 500. Did everybody plug it in like that? And what did you get?
0.
What does that mean in words? What? So you think he tossed it and 25 seconds later it's still not off the ground? Right. 25 seconds after it left his hand, it hits the ocean surface. That's what that means. 0 feet means it's on the ground, which in this case is the ocean surface. So it took 25 seconds for that pebble to fall to the ocean. Yes? Try it. Plug in 26 and see. No, but I'm just curious what it'll say. So plug it in. Okay? So I guess, which we all know is not the case, because that would mean it's falling at the same rate through the air as the water. And is that going to be the case? When it hits the water, it's going to slow down drastically, right? So yes, after 25 seconds, it's going to be a negative value. But negative 46 wouldn't be really accurate, because we all know that it's not going to travel as fast through the water as it did through the air. But it would be negative. Okay, if 15 seconds have gone by, what is the height of the pebble? So this time, what do we do? Right, so negative first, then in the place of t, 15. Okay, so after 15 seconds, that pebble he tossed is still 350 feet away from the water. 10 seconds later, it hits the water. What is its rate of change? How fast is it falling per second? 35 feet per second. Think about it, guys. It from 350 feet, listen, didn't it fall 350 feet from 15 seconds to 25 seconds, which is a 10-second span? And if you divide that out, wouldn't that be 35 over 1? So 35 feet per second is how fast it's falling. Okay, try number 2, both parts. All right, Devin is practicing golf at the driving range. The equation that represents the height of his ball is S equals negative 0.5 t squared plus 12t, where S is distance in feet, t is time in seconds. How high will the golf ball be at 10 seconds? So where do we plug in that 10? Both t places. And when you do, where is the height of the ball? 70 feet. So 10 seconds after he hit that ball is 70 feet in the air. What about 20 seconds after he hit the ball? So what does that mean? At 20 seconds, the ball is on the way back down though, right? Because it's lower than it was at 10 seconds. Why are every single one of these equations, why do every single one of them start out negative? The parabola opens down, right? In every one of these scenarios, the item or whatever's being kicked or hit or thrown goes up and then comes back down, forming a negative parabola, an upside down parabola, which is why all of these are negative. Okay, now let's see who our advanced students are. Try 3A and B. A is easy, B's the advanced question, so let's see who can figure it out. Jack throws a ball up in the air to see how high he can get it to go. The equation that represents the height of the ball is S equals negative 2t squared plus 20t, where S is distance in feet, t is time in seconds. How high will the ball be at 7 seconds? Well, seconds goes in t, so I'll put it right there. And when you did that, what did you get? 42 feet. So that means once he's tossed the ball, 7 seconds later, it's 42 feet in the air. If the ball is 48 feet in the air, how many seconds have gone by since he tossed it?
6.
That's one of the answers.
1.
Did anybody get the other answer?
1.
No, they're both whole numbers.
1.
How did y'all get the 6? Tell me that much. You just plugged in numbers till you found the one that made it 48?
Yeah.
Why did y'all all get 6 first? Because the other number's smaller, so I'm wondering why you wouldn't have got to it first when you started plugging in numbers. Like, what made y'all plug in 6 first? Okay, let's look at it. Right. Okay, look. This time they tell you 48 feet. So that number, since it's in feet, will go in S, because S represents distance in feet. So in this equation, the S will be replaced with 48 this time. And then the rest of it, we don't know. We don't know T. That's what we're trying to figure out. Couldn't you just simply move the 48 to this side by subtracting it over? And then what does this side now equal? 0. Now couldn't you graph that? Okay, graph it on your calculator. Negative 2t squared bring it up here. Okay, so when you type it in after you've moved the 48 to the other side so that everything's on the other side and you graph it, don't you see that it crosses through at 4 and 6? Well, if it's at 48 feet, how could you have two different answers for time? Okay, but in terms of this problem, what does it mean? Right, at 4 seconds on the way up, it reaches 48 feet, and then it goes a little bit higher, and then on the way back down, it reaches 48 feet. Okay? Does that make sense why we have two answers? Because one of the answers is representing when it reaches 48 feet on its way up, and then 2 seconds later, it's coming back down, and it's back at 48 feet. Okay, try number 4. Okay, S equals negative 5t squared plus 20t, where S is distance in feet, and then these t's are time in seconds. So if Kaylee's jumping on her trampoline, getting as high as she possibly can, the equation to represent her height is S equals negative 5t squared plus 20t. How high will she be in 2 seconds? Okay, after 2 seconds, she will be 20 feet. This must be some super trampoline. Must be like a circus trampoline. Okay, S equals negative 5 times t squared plus 20t. This time they want to know how high she'll be after 4 seconds. What does that mean? That means 4 seconds later she's back on the trampoline. Okay? Alright, turn to page 24. Okay, try number 1 by yourself. Example 1. See if you can do it. A high school football player is practicing his field goal kicks. The equation y equals negative 9x squared plus 45x represents the height of the ball, where y is feet, so I'm going to write feet above y, and the x's represent seconds. When will the ball hit the ground? Well, when the ball hits the ground, it's where? 0 feet. Well, where do we plug in 0? Y. Didn't we write feet above y? So that's where the 0 would go. When you just have 0 equals all that, couldn't you just graph that? So negative 9x squared plus 45x. Pay attention. Negative 9x squared plus 45x. And then you see it cross the x-axis where?
0.
At 0 and at 5. So that means x equals 0, x equals 5. Those numbers are in what? seconds. So wouldn't that make sense? At 0 seconds before he's kicked it, it wouldn't be anywhere, right? It would still be 0 feet from the ground because he hasn't kicked it yet. 5 seconds later, wouldn't it hit the ground? Okay, example 2. Jason jumped off of a cliff 480 feet tall into the ocean in Hawaii while vacationing with his friends. Now, that's a long jump. So really, this probably should have been worded, Jason killed himself by jumping off a cliff 480 feet tall into the ocean in Hawaii while vacationing with friends. His height as a function of time is modeled by negative t, or 16t squared, plus 16t plus 480, where t is time in seconds and h is height in feet. First, they want you to find and graph the x-intercept. So how do we do that? Graph it first. So in your calculator, type in the function y equals negative 16t squared plus 16t plus 480. Why does the graph look like that? Why can we not see the vertex of the parabola? Because it's 480 feet up there, and our window only goes how tall? 10. Like if I went to my window and I went up the y-axis to 500 feet, look what it would look like. See how now you can see it? It's so many notches they didn't even put them. Okay, so that's why the graph looks like that. So where are the x-intercepts? Negative 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. So your x-intercepts are at negative 5. So that's one of your x-intercepts. And your second x-intercept is at positive 6. And then if you're trying to sketch your parabola on this paper, you can just kind of do like this. And then we can't really see it because it's so high. And then it comes back down through 6. Now, which side of the parabola makes no sense? The left side. Think about it. He's jumping off a cliff 480 feet tall, so he starts up here and then he just jumps down into the water, right? So it doesn't really make sense in terms of this problem. That's not there. That's underground. Okay? Here he is up here on the cliff, then he jumps off into the water. So, no, that would be ground. You can't jump down into the ground.
No, that doesn't say that it's ground.
So, why did I draw an arrow? No, but why in this case? It's the ocean, so he can go below the ocean surface and continue down a little bit, right? How many seconds did it take him to hit the water? 6 seconds. Remember, this one is meaningless. So 6 seconds later, he hit the water. Okay, remember, tonight there is no homework. So tonight would be a good night to get caught up on late stamps. Pink sheets are due Thursday. Test is Friday.